So welcome back. So till now we have solved the two sum problem with the two pointer approach, correct? But there was one hidden assumptions in there, and that assumption was, what was that? The array was sorted. You are taking the input as a sorted array, correct? Sorted array you are taking. So now let's remove that assumption. I'm removing this assumption now. So mostly the real interview question will not always give you the sorted data, that is for sure. So our question become, after this removing this assumption, what if array is not sorted? Correct? So let me take one example to make it more understandable. Let some random number, okay, and let me take some target also. Take any 4 plus 4 8. Let's take 8. Okay, so we need to find all the pairs whose sum is 8. Can we directly apply the two pointers here just like in the previous example? No, we cannot apply the two pointer approach directly on this given example because two pointers rely on order. This is the order constraint then that help us into the movement of data. If you remember, if your sum is less than the target, you need bigger numbers, then you are moving the left pointer. If your sum is more greater than the target, then you have to reduce the number, then you are moving from right to left. Okay, so if the array is not sorted, then these things are not going to work. So two pointers rely on the order. Okay, so if I try to move the left or right pointers, I cannot make decision because increasing left doesn't guarantee that larger value, right? The same thing I was telling you. And decreasing the right value doesn't order you to, and you are going to get the next element, a smaller element. There is no guarantee in that. So two pointer need some structure and sorted data give that structure. Okay, so now we have two options. If array is not sorted and the problem is given, so there are two options. What is option one? Option one is that you have to create a structure, means you have to sort the data first. Okay, and option two, somehow you have to do this sorting in memory, use memory, extra memory you can say. So once you are taking the option one, then of course this will become the same problem. Once the array is sorted, then it is same problem. You can directly apply your two pointer, but in this we are breaking the order, remember that. Second, this is the approach that we can use here. In this we are going to use memory, so I can use the hashing technique here because for memory we prefer hashing. So let me talk about the approach one or option one. Okay, so in approach one, first you have to convert the unsorted array to the sorted array. Okay, when we are going to do this, so array will become sorted now. So once the array becomes sorted, so 1 2 3 4 4 and what was that, 5 6, right? 5 6. If you have done this, is sorted. Now you can apply the same logic we already have learned in the previous video, right? And this is going to run, there is no issue in that. Okay, and this worked beautifully, but there is a cost because we are doing this operation, one extra operation, right? And this extra operation is going to take some time, and that time complexity will be of sorting of array is equal to n log n. Okay, so and space of course order of 1, there is no change in that. So the only there is one more problem in that. In the order the element was appearing in the array, that is going to be lost. So order also lost, because you were sorting it, right? So maybe 1 3 5 2 is there. When you sort, 2 will become here, right? So the 2 was coming after 5, that order is lost, right? So this is the problem in that. So if the problem requires original order, then you cannot, this approach is not going to be work. Okay, if the question is saying, or interviewer is asking, order should be maintained. Okay, so then this approach 1 is not going to work. It's okay. Now coming to approach 2. What approach 2 say? It says, let's solve this problem without sorting, and we are going to use one hash set in this. So we are not going to sort it, then order will be maintained. Okay, so the key idea is that instead of searching, we remember what we have seen. Okay, so whenever any element is coming, so we are not going to search the element in this array, we are going to just remember what we have seen. So somewhere you have to mark this. Okay, this number already I have visited. Okay, so the core logic is that that we are going to use, if suppose a plus b equal to 10, and this a is nothing but the array, like 1 5 3 2 4, in this order is there. So a is 1, target is 10, right? So a is 1, target is 10, then what will be the complementary of this number, which is going to give this sum 10? So of course 10 minus 1 means 9. So you have to check in your hash set, is this number already you visited somewhere? Alright, you visited or not? Let me give one more number here. So if it is visited, then that number must be present in this set. If it is present, it means you find the pair. If no, then store the current number for the later iteration, right? So okay, so let me do this a dry run for this so that you can understand, then we'll write the code for this. Okay, so let me give take one example, the same example that I have taken here. In starting I have taken, I think, this one, right? So this is the number. So I am maintaining one scene variable, which is nothing but a set. It's initially it is blank, and this is the result when match is found. Okay, this is one array. So let me talk about the step 1. What I'm going to do in the step 1? Step 1, first number equal to what? Let me add the index also, 0 1 2 3 4 5 6. So at the 0, what is this number? 3. Target is 8. So what number you need? 8 minus 3, that is 5. So does scene contain this 5? Scene is blank, is not found. So I am going to add 3 in the scene. So now scene is nothing but it's having one element, that is 3 now. Let's move to the step 2 now. So in step 2, next element is 4. So number equal to at the first index, that is equal to 4. How much you need? 8 minus 4, that is 4. Does your need this variable, does it contain scene is having this number? No, because scene is having only 3. So I'm going to add. So now scene become 3, 4. What will step 3? number equal to 4 again. 4, how much you need? 8 minus 4, that is equal to 4. Scene is having the 4. Yes, now I found out. So it means pair is found. This current element and this element already present. So what I'm going to do, I'm going to add in the result. Okay. So found, pair found. I'm going to add result. So add, what are we going to add it? 4 comma 4. This is the number that we are going to find the pair. Okay, I'm not adding the index. If you want, you can do the index also, but for that we need some change. For the current I'm just adding the number values. Okay, in the same way I'll move to the step 4 now. Step 4, my pointer is here now, 2, right? So element is 2, so I'm going to take 8 minus 2, that is 6. Does scene have this? No. I'm going to add this. So scene will become now 4 comma 4 comma 3 comma 4 comma 6. Correct? Now coming to step 5, I'll move pointer again on the next. Coming to 5 now. So how much you need? 8 minus 5, that is 3. 3 is present in the scene. Yes, found. Pair is found again. So I'm going to add this 5 comma 3. Correct? Which sum is 8. So in the same way, we'll keep on doing this and keep on adding this result. So you get a list of results which is having a pairs which is having the sum of 8. So you try to do this. Okay, this is step in S6. Let me do the S6 also. It's a 6 and last element is 4, so just remember 6. So you need how much number? 8 minus 6, that is 2, and 2 is having in this? No. So I'm going to add this scene, so it will become like 3 comma 4 comma 6 and 2. Correct? Now step 7. In step 7, last element is I think 6, right? 4. So the sixth element is 4. So how much you need? 8 minus 4, that is 4, and 4 is already present here. So pair is found. But if we are going to add 4 comma 4 again in the result, it's already present actually. So you can add it, but if duplicate is not required, then you can remove this. So for now I'm adding, so I'm going to add the result again 4 comma 4. Okay. So hope you understood this. The only challenge that you can face, what if you are getting the duplicate pairs, right? In case of duplicate pairs, if you want, we can do something. Duplicate pairs, here there are two type of duplicates. One is like 2 comma 6 and 6 comma 2, both are same, right? So you must avoid this duplicate. So what solution will be that? You have to normalize our pair. Always store smaller first. Okay. So always try to store the smaller first. Smaller first means which index is the smaller. Try to store that. So it will be matched and it will be removed. Okay. So when I write the code for this, you might be understanding this, like how we are going to remove this. All right. So let's do that. So in the next lecture, I'm going to write the program for this and we'll see this. So hope this variation of the problem of 2 pointers with a given 2 sum, this is very interesting, and normally in interview also they used to ask the variation of the basic problems. So when we're trying to solve any problem, try to go up and down of those variations also. Okay, something is sorted. What happens if something not sorted? If only positive integer is given, maybe someone is saying, okay, what about the negative integers if you are passing? Okay, so those use cases you should think. Okay, so see you in the next lecture.